We are now moving into the fascinating realm of agentic AI, where multiple smart systems work together to automate complex tasks. And this is a hands on session that will show you how to build real world automation tools. Please welcome Sijohn Mathew, Google developer expert, presenting his workshop, Agentic AI. Let's start.
Thank you. Thank
I
you,
stop
Anna.
sharing. You can share your screen.
Sure. Give me a second. Uh, Slideshow. Oh, sorry. Just a second. Um,
Take your time, okay.
Grant access.
But mainly we need follow agenda, so you have time just till 6 p.m. I know with workshops it's not so
Yeah,
easy to follow agenda, but today we have full agenda. We haven't paused in.
no problem. Yeah, I will cut short few of the things. All right. So, good evening, everyone. My name is Sijohn, and today we will be going through. This is originally developed as a hands-on session, but in the context of doing it virtually, it's a little bit tricky to do hands-on. So basically, normally I used to give cloud credits, and then you can do programming with me in parallel. But I have changed the format a little bit here because we are doing virtual. So the format will be like I will run through the slides and the concepts for first 15 minutes. I won't bore you with too many slides. Then I will show you how do we really develop agents very quickly in 10 minutes, or like even with less than 5 lines of code in Python. I hope you all are at least familiar with coding and development. Otherwise, just listen to the concepts, because even listening to the concept will be much interesting, because these days how things are getting evolved and how agents can be developed in the frameworks like ADK or similar frameworks, which we will go through soon. And then I will show, as part of the our agenda, like build a simple agent which can do a OCRing kind of thing and extract the line items from the receipts and insert into a database. Basically, I'm preferring here Google Cloud and BigQuery as a database here, but it's up to you to do it to any other databases. All right. So, without much further ado, I will not cover all these topics because, in the interest of the time, and then our agenda is more on doing hands on. But just a quick introduction. Almost, I think now everyone would have been heard about agents and AI. It's like Gen AI and AA agents. It's too much of information overload these days. But just to set the context, what is an AI agent and what is it differ from a normal chatbot? So, in its pure form definition, it's basically a software system that doesn't just answer the question, but it's capable of perceiving its environment, and then it can do reasoning and make decisions and things like that. So that is what it makes an AA agent differ from a normal chatbot. Or you can even consider, like, I mean, in a real world example, if you take a AI chatbot, like what you normally use, like your chat GPT or Gemini or any kind of cloud or things like that, it acts like a, what is it, a waiter in a hotel. So you ask something, he will deliver, or the waiter will deliver. But in case of an AI agent, it is more proactive than a reactive chatbot. When I say proactive, it do multiple things, or like it can break down things into the complex task into different smaller tasks. That's where the AI agents excel actually. In a simple example, if you can see that agent who is a travel planner, it acts like your personal assistant. So it breaks down the complex task of travel planning to simpler task. First, it can check my calendar, then it can go and search for the flights, it can go and search for the hotel rooms, it can go and find out the let's say the cheapest rates, and then finally book and then make the payment. So that's how uh, you can define like kind of a task is broken down into multiple smaller tasks. And that's exactly what we are going to see and do in a practical example. All right. Enough of that AI agent explanation. And this is just a quick overview of how it is evolved. So we have all seen LLMs and the prompts, like the familiar chatbot interfaces. Then came LLM with the retrieval. So because if you ask the general things to LLM, it's easy to answer. For example, what's the capital of Germany or what's the capital of Sweden? It's easy because it's on the LLM knowledge. But then later on, if they I mean, if you want to get answers based on the context, basically on the information what you are working on, that is called where the context based answers came in. That's where the retrieval augmentation concept came, that is called the RAG. If you are not familiar with that, the expansion is called retrieval augmented generation. And then came RAG with the tools. So basically, tools, when I say connecting to your local databases. For example, if you are studying in a university will have a local database of information about the student, and then the all kind of facilities available and things like that. So if you want to ask an LLM a question about what is there inside your university or inside your office premise, then LLM doesn't know that, so it has to connect to the tools. That is where the other next evolution came. And all these things wrapped together become like kind of an agent, because it has to work in an orchestration to build a reasoning loop. And then comes multiple agents. So as and when the system grows, it has to communicate each other. So then the protocols came in, like for the agents to communicate. So that's where the protocols like A2A, agent to agent protocol, and frameworks to build and manage those agents became more and more important. Like I said, this is again a complex diagram, but what makes an agent? I will just touch base on the core components here. The core components of an agent is basically the brain of the agent, which is nothing but the generative AI models. Either it can be Gemini or any kind of models. Then comes the definition about the agent, meaning like you define the agent and say to the agent that these are the goals you have to achieve, these are your instructions, and these are the tools you can use in my agent. So that is where you are defining the agent. Then you have the set of tools. It can be like kind of calling a function, calling APIs, or calling databases, like the example I said, your local databases or local APIs, because those wouldn't be in your generative AI models training memory, or in the training data set. These kind of small nitty gritty details are not there. So it has to access, if it has to access those data, then you will have to provide it with the tools. So tools is a very important part of the agent. Then comes the orchestration part. So it has to be, I mean, there are tools, there is an agent definition, its goals, then there is a generative AI model, then it has to orchestrate everything. So there comes the orchestration frameworks. Like for example, today we are dealing with ADK, which is an open source framework from Google, which is called Google Agent Development Kit. So then the whole thing has to run somewhere, right? That's where the agent runtime comes. And in the Google Cloud premises, it's called Agent Engine, and it can be deployed on any other platforms also. It need not be in an Agent Engine. It can deploy to a Kubernetes cluster, or it can be deployed to a serverless environment, like that. And then when an end user starts using it, that is where you start querying and you get a response. So I will showcase how to create a very simple agent using the ADK framework with just 5 lines of code. So it's, I mean, the wrapping around of all these things are now very simplified, so that the abstraction of what is happening inside, you don't even need to bother about that, because these frameworks are so mature enough now to wrap up a lot of boilerplate code for you. So I was talking about the same thing, Agent Development Kit. This is an open source framework to develop, test, and iterate on multi-agent applications. And you have the option to build in Python, either in Java or in Golang. So these are the three flavors available for the Agent Development Kit to develop. So you can develop in any of these three programming languages. So this is bit of more of a theory session. So I will skip through this and I will touch base only on the very important thing, basically. Um, so, like I said, by design, this is multi-agent. So you can compose many agents and tools in a hierarchy in ADK. Then it has got a very rich tool ecosystem. Basically, if you just want to do a agent with a Google search inbuilt in that, it's very easy. I mean, you just plug a tool and say that, okay, I need Google search. So, and then you would have heard about MCP tools if you are working on the AI space. It's very easy to embed those kind of things, and it can actually work with multiple models, even though it's a product from Google. It's not only with Gemini, it's built for Gemini in terms of like in performance and everything. It is optimized for Gemini, but that doesn't restrict you to use only Gemini. It's, you can use any other kind of Gemini models. Then orchestration, these all are like the nitty gritty details. You can read through this, I can share this after the session. One core thing I want to focus here is that when you build agents, some people are confused, like, why do you need an agent? Because this is same thing like our old school or before the Gen AI days. The It's kind of a normal workflow automation. In a way it is correct, but what is the difference here? In the old way of doing workflow automation, you were having a very deterministic flow, meaning that in the programming language you will be writing like, okay, if this happens, go here, if it doesn't happen, go there, like a if else block. So in the agentic workflow approach also, there is deterministic flow. There we can use the old approach, but there is a non-deterministic flow also, because the primary user interface here is natural language. It's not like you are actually clicking some buttons and then, okay, if you click on this button, this is the only information that is passed, so then it is easy to make the if else decision. But when it is a natural language, a user can ask questions in very any different way. So that is where the non-deterministic flow comes in. So then the brain is the Gen AI models or the AI model, the LLM models, and model decides how the flow should move forward. So that is where the non-deterministic flow comes in. And then when you build agents, you may need sequential agents, parallel agents, and looping agents. So there are certain subtasks. For example, the travel planning agent I mentioned, uh, first you need to check the calendar. So maybe that will be a sequential agent, because if my calendar slot is free only, it has to go and search for the hotel and the search for the flight for that date. So first calendar checking, that could be a sequential agent. So after that, the two parallel agents can work in parallel, the flight searching and the hotel searching, because you got the input from the sequential agent, from the calendar checking agent, and then the other things can work in parallel. And then once all the results come in, a orchestrator root agent will assemble all this information and then respond it back or act on it. So that's how this orchestration come into play. um, if you are familiar with the agentic world, you would have heard at least some of these frameworks. So the framework what we are talking today is called the ADK. So if you look at the ladder, like I said, Now you can categorize these agentic frameworks in different levels of abstraction. So the base level is, if you are a hardcore developer, if you are developing something in Python or Node.js or any programming language, it's absolutely open and absolutely free to create your own agentic framework, or not even a framework, your own agents, by doing it in your own way of how you program. But then you will have to handle a lot of boilerplate code. So then comes the second level of abstraction, or the initial frameworks, the initial days, the LangChain, which was the most popular. So LangChain was a bit of a low level orchestrator, wrapping so many of the boilerplate things. But then came, okay, why do you need, why do a developer need to bother too much about the basic things which is happening under the hood? So then a wrapper framework came. So that is where this ADK, and then this AutoGen, this is from Microsoft. LangGraph is actually a wrapper on LangChain. Then the famous Crew AI and other small agent and things like that came in. And then there is another level of abstraction came in, where not a developer level person, like a business user. In the corporate world, when you say business user, a normal user who is not hands-on on coding or things like that, they want to do drag and drop and create agents. So for example, you are responsible for creating social media post every day or every week for your company. Then normal way you can do is, you research on a topic, you go and copy paste your company information, and then do so many things and research on that topic using either some kind of chatbots or using Google search and other things, and then come back and then assemble it, and then create a find a suitable image and then post it on the social media. But now with these things, with agentic approach, what you can do is that you can have the one agent doing the research for you, second agent creating the summary of that research topic, third agent generating an appropriate image, and the fourth agent is basically waiting for your feedback as a human in the loop, and the fifth agent can do the posting to social media. So then these kind of things can now be very easily done even using a drag and drop tools, like, if you have heard about tools like N8N, or even Google is having something called Opal, which is still available only in US market, I think. So that is the level of abstraction happening in the agent space. These are like coding examples. I will walk through when we do the code. And instructions, let it be. Yeah, the function tools. So this is the example what I was telling. Like, tools are nothing but our old school Python functions, which are like predefined functions. So agents without tools is, I would say, mostly useless. Otherwise, it's just for asking questions and then certain things. But tools are nothing but, it can be calling an API or calling a database and getting information, and then at the end writing some information back into the database. So these are the functions a tool can actually perform. And tool is one very critical component in the agent ecosystem, basically. So in this example, if you see, search hotels is a tool. Actually, internally in that tool, what we may be doing is that it could be going and searching in Google search, or like kind of any specific hotels portal, or like any like flights.google.com, so something like that. So the agent is responsible for getting the question, and then so the beauty of these frameworks are like, there will be a root agent, and based on the question asked by the user, the agent will select and decide, okay, this question, this is the tool it has to use. And maybe in the same question, it has two three things involved in that question. So the agent will decide which all are the tools to be picked. So for example, maybe I am asking question about the flight and the hotel, then it has to pick both the tools. So here we are not actually hardwiring, okay, if this statement was there or that statement is there, pick this tool. No. So the LLM is the brain. So LLM decides how to pick the tools. We just need to mention, okay, these all are the tools available, and then LLM will go and pick it up. And this is again an advanced concept, agent tool. um, you can use another agent, like I would say sub agent, as a tool also. The advantages and of that we will take it up maybe if in a advanced lesson. And this is also an advanced concept, but it's a very important thing, and it's a very useful thing when you start writing agents. This is called callbacks. And callback is nothing but, because as a developer, or as an organization which is making agents, you should have a opportunity to interrupt when the agent respond, or when it handles a request and response. So this is the opportunity where, when you write agents, like the same way you can call tools, you have the option to do callbacks. Meaning, when there are these are the available callbacks. This is called before model call, after agent call. So let me take an example for the before model call. So what happens is that a user is asking a question like, for booking a hotel. Let's take the travel planner example itself. In that, every time when this question comes, it will first call the model to decide, that is the brain, to decide which all are the tools, and how to break down this complex question or a simple question into smaller subtask. But even before that, let's say you want to put a guardrail, like you are before model call can be used to check whether, if the user is abusing the model or asking questions mostly irrelevant to this topic. So these are the things, or for any other reasons. So, and also similarly, after agent callback or before agent callback, before tool callback. So for example, this before toolback, and an example I can say is that a tool call is nothing but a database, right? A data, not only database, but an example is a call to a database. So let's say a user is telling delete all these records from the database. We can put guardrails in different ways, but this is an example I'm just taking for simplicity. Before tool callback, we can actually check if the user is asking for certain things like this. Then you never even call the tool, because when you write these instructions, we can actually explicitly say, but explicitly in the before tool callback, we can actually make the agent to behave in the way we want actually. So for example, let's take this example of before model call. Like if Expedia in user message is lower, then sorry, I can't help with that list. So when the user is asking like, okay, book a travel, do a travel planning using Expedia, then our policy doesn't allow, or let's say our company is not allowing the using Expedia, then we can politely respond telling that, okay, sorry, I can't help with that. So this is actually a very deterministic way of telling in the agent itself, don't proceed with the agent even to the other levels actually. Even streaming, I will skip it. Input output schema, this is a very important concept. This is if you are familiar with Python, you would have heard about pydantic. Pydantic is equivalent to, I would say, JSON structures. So let's say, because when you develop applications, one very important thing with the earlier LLM days is that LLM will always respond as text. So when you get the results in text, in certain scenarios, if you're working with applications, especially in the UI based applications, if you want to display the results in a more structured way, it's very difficult if you get the response in a text or something like that. So in that cases, or even if you want to write the output to a database need a structured way, like unlike the document databases like MongoDB. If you have a Postgres or a SQL server, you need the response to always comply to a specific schema. Let's say story idea. You are creating a simple agent to generate story ideas. So we say to the model, to the agent that, okay, my input schema will be always a story idea class, which means like I will always pass target age and number of pages and the idea in a string. So this is a very well defined structure. And then when the output comes, we are telling the model or telling the agent that the output schema should always conform to story, which is basically the story should have a title and then it should have pages. Pages means it's a list of string. So each page will have the contents of the story. So this is an example. So similar to the old way of how we defined schemas. So now the agents and the LLM can actually obey to all these schemas, so that it's more easier and convenient when we work programmatically. So with that, I think I will wrap up with the slides because it's already 5:30. We have only 30 more minutes. So let me switch the gears. Hopefully you are able to follow at least something. So whatever we saw right now in the slides, I will showcase how to create a simple ADK agent with 5 lines of code. And this is in Python, but if you're a Java developer, you're free to create it in Java or even in Golang. Okay, let me close the slides. Stop sharing. I'll share my VS Code. Okay. Uh, Hope you can see my screen, which is my VS Code screen. So this is a very, I mean, before going into the final outcome of this, uh, my session title, which is basically creating a OCR agent, I just want to showcase, because if I show that, it will be like too much of codes. But with this, you will be able to even understand it in a very basic level. So this is a very, it's just an empty VS Code terminal. So what I will do is that I will bootstrap a Python project here. So I am using a package manager called UV. If you are a Python developer, you might be knowing different package managers like Pip or Poetry. You are feel free to use any of those. But I am lately I'm using UV a lot, and I like it because it's quite fast. So basically, this is nothing to do with agent. This is creating a the first line UV virtual environment, which means like I'm creating a Python virtual environment here, and then I will initiate init a UV project here, UV init. I mean, like it's a Python project. So in the old way of Python things, it's the requirements.txt. So here it is the pyproject.toml file. It gets created, and then in the dependencies, we will basically add a ADK dependency, Google ADK library we will import. So for that, what we will do is that we will ask UV to I don't know. Let's move into the. I need to activate the virtual environment what we created right now. We are in the virtual environment called the VENV what we created right now, and let's add the so the dependency got added, which is the Google ADK. And from now, we will use ADK. Till now, everything was Python. We were setting up a just a virtual environment and then creating a, I mean, importing all the Google ADK library. So now we will start with the ADK. So let me clear this. So what we will do is that for creating an agent, I'm going to create a very simple agent which can actually do a hello, how are you? And I mean, it's like your normal chatbot, either you use it in ChatGPT or in Gemini. So we will just create a simple agent, and then from there we'll take it forward. Let me do one thing. I need to stop sharing and do the full screen sharing, entire window, because I will swap between the windows. So how do we create a ADK? Create. I'm just creating a new agent. Let's it called Ahlen demo agent. Okay, and see here what it gets created. So it's bootstrapping, and at that time it is asking some basic questions, which model you are going to use, and by default it's the Gemini models, but you are feel free to use other models also. But I'm just, for the sake of simplicity, we will go with one, and then it will ask two basic questions. One is, do you want to use Google AI or Vertex AI? Google AI is nothing but, if you are familiar with AI Studio, that is the Google AI. So in the I mean, not AI Studio, I mean the API, the Google Developer API, if you want to use that, and then you have to generate an API key. Since I'm coming from a cloud background, mostly in the corporate network, corporate environment, you will be doing more of cloud. We will use Vertex AI, which is the cloud way of accessing these models. This is purely for accessing the models. So then it asks for what is my Google Cloud project. So I'm just giving SM Gemini Playground, which is already there, and it is asking which cloud region, Europe North. These all are like the basic things. And now if you see, it has created an agent here. And if I just open the agent, it has bootstrapped like this. So I'm a root agent, and I'm using a model called Gemini 2.5 Flash. And the name of my agent, I can change that, called, now it's called root agent. And description, I'm a helpful assistant for user questions and answer user questions to the best of your knowledge. So now my first agent is ready. So how do you test this? So the ADK framework has given multiple ways to test it. I have skipped that slide, actually I should have shown that. One is using a simple web framework. By running ADK web, it will spin up a small server just for you. For this is not for production use, this is just for testing purpose. And here you can actually go and test our agent. So now our agent is running in localhost 8000. So if I open this, see, I got a window like this. I can zoom in a bit more. So I got a chat window like this. So now I am communicating with my agent. Hello. So see, because, and you can see here it has started communicating, because this is a very helpful agent. So it will answer any questions like, hello, what's what is the uh, uh, speciality in Poland, Germany? I don't know whether it will answer. Let's see, because it has got a model to use, so technically it should answer yes. So it's a town, la la la, and all those things. So now it's, you will ask me like, what difference does it have than the normal a chatbot what you daily use it in your world? But this is where the cool thing comes. Let's add a simple tool to it. Let's say my agent is supposed to bring what is it, get the current time of a city. I mean, just a simple example I'm taking. I want to showcase how an agent will become, not using its own brain, rather it's using our tools. So I have pre-created a function. This is just a mock tool implementation. So let's implement a simple Python function called get current time. And what is this function doing is return the current time in a specified city. So user will be asking a city, for example, Ahlen, or I am from Stockholm. What is the time in Stockholm? Then we right now we are hard coding the time to, let's say, 1730 or 5:30 p.m. Okay, so whatever you ask, it should actually use this tool, and the model's brain should be dumb, and it should always using this tool to answer it. So that's what we are telling the model. So in this description I have to change it now, because you are not a helpful assistant for any questions. Tells the current time in a specified city. I'm getting the vibe coding help, that's why it's getting auto typed, so it's cool. So here we are saying you are a helpful assistant that provide the current time of a given city, and here I am going to specify use the get current time tool, which is basically this is my get current time, and here you are expressing everything in very natural language. Okay, and get current time tool to fetch the time. So let's see, it will, and then at the end you have to mention what are the tools available. Tools get current time, so it knows, okay, this is the time. So let's say we had two different tools like get current weather also, and we hard code and say something, then we can just pass on telling, okay, get weather tool. But right now in the interest of time I'm not doing that. So let's reboot our servers, and let's see what happens when we do a fresh chat. uh, okay, can you okay, yeah. So right now I'm just asking hello. See, now the agent's behavior and all those things have changed. Hello, I can tell you the current time in any city, which city you are interested in. So let's say Stockholm. Right now the time is not 5:30, but our tool has hard coded it as 5:30. So whatever is the case, if model also knows it, okay, this is wrong, it is forced to use the tool. So whichever city you say, let's say Owen, it should return current time in Owen is 5:30 p.m. Yes, but now if you ask something else, tell me capital of Germany. See, I can only tell you the current time in a specified city. I can't tell you about the capital of Germany. So that's how the controls what we build in agents. So the agent is responsible to do certain things, and that is the role of agent. So if you, I mean, it's quite easy to open up this agent to do so many other things, but I'm just showcasing this to see how convenient is to develop an agent using frameworks like ADK. So, like I promised, it's more than 5 lines of code, but the root agent, when we initially started, it's hardly 5 lines of code. All right. So now we have only 15 more minutes. So let me switch again. Let me close this. So what is the agent we are going to finally build? Let me bring up my other window. Just give me a minute. New window. And where is my environment? Okay, before doing that, let me showcase what the agent V is going to do. So, like I promised in the original uh, discussion, I have deployed the agent. I will show you the code of the agent and what it is doing. So, what exactly is the outcome of that thing? So, this is a document extraction with AI tool. So, what I'm doing is that I have a tool which extracts all the receipt details, and then it will identify each line items and the supplier name, and then the date of the receipt, and then maybe an invoice number, and then finally it inserts that data into a database. So it involves multiple steps, even though it appears very simple. But if you want to write code, then it appears a lot of steps. One is it has to first accept the image, then it has to do an OCRing, which is nothing but the recognition of the text in the image. Then once it analyze and extracts that text, it has to understand each and every line items. In the old way of doing things, it would have been like kind of you have to train each and every receipts. So and then it has to finally insert that data into a database. So but now with the agent, how I will show you how simple it is, but right now let's see how it works basically. So right now my agent is running. When I say extract information, there is an OCR agent, then there is a uh, which is basically the extracting agent from the image. See the output. So this, I have two line items in this receipt, stake minute and we can start. This is Swedish, and this is the price 275 and 195. It clearly extracted it from the text, and the total price, and then the vendor name Urban Delicia Wagon, and then the invoice number is 049. So it's perfect. So this is the thing what we are building. So sometimes it's easy when I show the final product and then thinking from the reverse, it will be more easier for you. So what did we do? So before that, let me show you the diagram of the architecture where it is. Agents draw.io. Okay, I can show it in my docs. Okay. So what was it doing basically? It was doing, a user is asking for a question. In this case, the question was an image, an uploaded image. And then my root agent, which is the orchestrator agent, it it understand, okay, user is asking for a question, and it has got a predefined row goal and an instruction. So the if you look at the code, it will say clearly that to the root agent, you are an expense tracker orchestrator. That's all. And the description says orchestrate the entire expense tracking workflow from OCR. OCR is nothing but optical character recognition. But this was an old way of telling this. It is not really now an OCR. OCR was the old way of like when you do a scanning and then optically character is recognized. But the concept is still called OCR. So that's the reason why in the description I have given like that. But you need not give a description like this. And to the logging, so it's very bare minimum description I have given. And unlike the earlier way of defining tools, here I have delegated this task to three sub agents. So you will ask me the question like when to use sub agents and when to use tools. I will come to that point. But here we have three sub agents. First agent is the extractor agent. Second agent is I'm categorizing these receipts into different category. I'm asking the agent to decide on the category, like if this was for a dinner or if this was for a grocery purchase or that kind of things. So I'm asking the second agent to categorize it. And then I'm asking the third agent to finally log that results into a database so that I can at the end of the month I can actually summarize it and see, all right, these were all my expenses daily. So this was just a fun project. So like I said, now this was the flow of event happening. So the root agent, it got the receipt, then it got the first extractor agent extract the text in that receipt, and that text was extracted, and then the whole output was defined as per a schema, and that was given to the second agent, which is the category classifier agent. And then the category classifier agent has classified the category and prepared the output so that the finance logger agent can call a tool which is called the BigQuery tool call and write the results to a database. So it's as simple as that. So I have a full instruction of how to run this, but normally, like I said, this is a hands-on lab. But you can actually, if you are interested, you can actually play around with this. In the first page, I have given the link to this documentation as well as the GitHub, which is a public repo, which in my GitHub repo, the whole code is there and all the instructions to run this code. So I will just quickly walk you through how this root agent is and the sub agents work. And by the time we will reach 6 o'clock, I think. So how is this root agent working? So root agent gets this thing, like I said, and we have defined here as a sequential agent. The reason is because, like I said, this all these steps has to be sequentially executed. But if, let's say, if this was for some other task, I can define it as a parallel agent. So let's check what this extractor agent is doing. So extractor agent is doing, and in the description says that, because this description and instruction is really very important, because don't think like the old school way of giving coding comments. This is actually the core and brain of the LLMs. So using this description only, the root agent understand what each sub agents can do. So this description has to be very neat and clear. So the description says parses a receipt image and extracts structured data. And so this description is used by the calling agent, and the instruction is used by this agent on what it has to do with the input what it received from the other agent. So here in the instruction, you are saying that you are a character recognition agent given the path to an image and all those things, and asking it to exactly extract the output in a defined format. So I am asking it to give me output in a schema. So that schema is defined as a receipt. So this is a very old way of defining things. Like if you do a JSON structure, we have the vendor name, transaction date, total amount, then line item, which is actually a complex type, which is having description, quantity, and price of the items. And then the category. This category is the one which is being handled by the category agent or category classifier agent. So if in this place the extractor agent, when it sends the output as a receipt object, it will be missing the category. So then the root agent receives the output from the OCR agent or the extractor agent. Then it passes that output as an input to the second agent. It this order of agents, sub agents listing here doesn't matter. You can just mix and match. But the root agent has the brain to understand. Okay, it has to call the other agent now to get the classification. So it will actually call it, and here we have actually mentioned it here that you use these agents for this purpose, and also it will use the description of the other agent. So here it describes classify the expense category based on the receipt data, and we have given examples like the possible categories are dining, grocery, fuel, travel, entertainment, and others. So it will simply classify it and get it back. So here it doesn't need the image because already the data in the image is extracted by the previous agent. So this will be like a more faster sub agent. And then the third sub agent, what it is doing is log the output into a database using a tool call. So here, if you see, this is the tool, and the tool will be basically, in my case, it's a BigQuery tool. And this is a typical way of writing the output into a database, identify the table, and all those blah 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 things. So I'm not going into the details of this code. And at the end, if you run this, that's what I showed it in the UI. If you run this, you will be able to simply, because if it is in the old way of doing things, it has to be a lot of things. Once you get the image, you have to use a different library to extract the data out of the image. Then after that, you have to classify that particularly based on some kind of rules what you've written. If these kind of items are there in the line item, then it will be like a dining, otherwise it will be a fuel. And if it is a mix of things, then it will go completely haywire. So, and then finally writing something into the database by following certain schema. It's all simplified by just this many line of code. And that is where the power of agentic framework comes, and that is one of the framework is ADK. If you are a developer, I would encourage you to go and try it out. I can share a couple of links more, and you can follow me in LinkedIn, and you can ping me directly. I can share that slide if anyone wants to. I think I close the slide. So this is my LinkedIn. You can ping me directly, and this is the GitHub repo where I showcase the code. So I have stopped 5 minutes before so that people will get a break before the next session. So I don't know whether they can ask questions, but I'm not really sure about that. Otherwise, thank you for today, and have a wonderful rest of the evening. Thank you, Anna.